Welcome to online lecture series in organic chemistry. In this video, we are going to discuss the alkylation or arylation reactions of organometallic compounds. A chemical reaction of metal halide with alkyl or aryl organometallics, it is generally called as alkylation or arylation reaction. In this alkylation or arylation reaction, there is a substitution of one or more halogen atoms of metal halide by alkyl or aryl groups from organometallic compounds, and there is a formation of new organometallic compound. So we'll take examples. For example, when magnesium halide, it is treated with alkyl lithium, this is organometallic compound, then alkyl group from organometallic compound replaces one of the halogen atom of magnesium halide and we get RMgX. This is the Grignard reagent, which is new organometallic compound. So in this way, the lithium alkyl lithium, that is organometallic compound, reacts with magnesium halide, and there is a replacement of halogen atom from the metal halide by alkyl or aryl group of organometallic compound, and we get new compounds. Another example, when zinc halide is treated with organometallic compound Mr, then this alkyl group of organometallic compound replaces halogen atom and there is a formation of R2Zn, dialkyl zinc, that is organometallic compound, plus Mx. Similarly, when aluminium chloride treated with alkyl lithium, then this alkyl group replaces halogen atoms and there is a formation of trialkyl aluminium, that is new organometallic compound. Boron trichloride, when treated with trimethyl lead, then these three halogen atoms, chlorine atoms of boron, these are replaced by methyl group and we get trimethyl boron and there is a formation of lead tetrachloride. Similarly, when stannic chloride is treated with organometallic compound, that is Mr, then these four halogen atoms or chlorine atoms attached to tin, these are replaced by alkyl group and we get tetraalkyl tin, that is new organometallic compound. Lead dichloride, when treated with alkyl lithium, then there is a replacement of halogen atoms of lead by alkyl groups and at the same time oxidation number of lead is also increased and we get tetraalkyl lead. Similarly, when germanium tetrachloride is treated with organometallic compound Mr, then there is a replacement of halogen atoms of attached to germanium by alkyl group and we get tetraalkyl germanium as a new organometallic compound. Similarly, arsenic trichloride, when treated with organometallic compound, that is AlR3, then these three halogen atoms attached to arsenic, these are replaced by alkyl group and we get trialkyl arsenic. At the same time we get aluminum trichloride. So in this way there is a alkylation or arylation reaction. In alkylation or arylation, there is a substitution of one or more halogen atoms of metal halide by alkyl or aryl groups from the organometallic compounds. This is called as alkylation or arylation. Now next important reaction, that is the reaction with protic reagents reaction of organometallic compound with protic reagents. Now protic reagents means the reagents carrying hydrogen or proton, for example water, alcohol, hydrogen halides. These are the protic reagents. So first of all, hydrolysis of organometallic compounds. So alkyl or aryls of many main group elements readily react with protic reagent like water and undergo hydrolysis. For example, so this main group organometallic compound MRN reacts with water. There is a hydrolysis of this organometallic compound and we get MOHN plus hydrocarbon. So mostly there is a formation of hydrocarbon at the time of hydrolysis with water. So these hydrolysis reactions usually involve the nucleophilic attack by water and the presence of vacant orbitals on metal atom helps for the hydrolysis reaction, as these vacant orbitals can readily attract the electron pair from the nucleophile, that is water. And rate of hydrolysis depends upon electropositive nature of metal. Greater the electropositive nature, greater is the rate of hydrolysis. Then polarity of metal carbon bond of organometallic compound and associative tendency of metal alkyls. Now the elements of first three main groups, that is alkaline earths or alkyl group, alkaline earth elements or alkali metals. So alkali metal organometallics and alkaline earth organometallics, they readily react with the water and there is a evolution of hydrocarbon. For example, N-butyl lithium, this is organometallic compound, reacts with water. So this one of the proton joins with this alkyl group, there is a formation of butane and we get LiOH. Actually water when dissociate, there is a formation of H plus and OH minus. OH minus acts as a nucleophile and this nucleophile attacks the, as I said, the electron deficient metal, because metal contain vacant orbitals and therefore this OH group joins the lithium and hydrogen when combined with this alkyl group, there is a formation of hydrocarbon, that is butane. Similarly, Grignard reagent methyl magnesium bromide, when reacts with water, there is a hydrolysis. This OH group attacks the electron deficient metal and there is a formation of MgOH Br. At the same time, this proton joins with this alkyl group and there is a formation of methane. Actually alkyl group attached to metal in organometallic compound, it is a carbanion and therefore it joins with proton. Similarly, tributyl boron when reacts with water at high temperature, there is a formation of the another organometallic compound and actually there is a replacement of one of the alkyl group by OH group and we get hydrocarbon. Now here most important thing is the less electropositive boron reacts with water at high temperature. Boron is less electropositive. Here magnesium is more electropositive or lithium is more electropositive. These reactions possible at room temperature, but reaction with the organometallic compound of boron possible at high temperature because boron is less electropositive. Now reaction with another protic reagent, that is alcohol. So the organometallic compounds of alkaline earth metals like dimethyl beryllium reacts with alcohol, that is methanol. Then there is a replacement of one of the alkyl group of beryllium by the OMG. So there is a from actually methyl, one of the hydrogen is replaced and we get MEH. So that replaced hydrogen joins with this methyl group of alcohol and there is a formation of hydrocarbon, and in this way out of two methyl groups, one methyl group becomes OMe. Okay, so next is trimethyl aluminum. When reacts with methanol, then again there is a formation of, or one of the methyl group of aluminum, it becomes OMe and there is a formation of hydrocarbon MEH. Now reaction with benzene. Benzene is another protic reagent. So phenyl lithium reacts with benzene, actually it should be C6H6. Then there is a formation of phenyl lithium plus benzene, PHH. So reaction with hydrogen halide. Lithium, organometallic compound of lithium, that is alkyl lithium, reacts with hydrogen halide and there is a formation of LiX and hydrocarbon. So this alkyl group replaces this hydrogen from HX and there is a actually formation of RH, or this alkyl group joins the hydrogen, actually there is formation of RH and LX. So tetramethyl lead also reacts with protic reagent and there is formation of PbMe3X. So here one of the carbanion, it is replaced by halide and this hydrogen joins with Me, or proton joins with this carbanion and we get hydrocarbon. Then triphenyl arsenic reacts with hydrochloric acid and there is formation of complex ion. Similarly, trimethyl antimony reacts with hydrogen halide and there is a formation of Sb, that is antimony Me3Cl2 plus hydrogen. So there is a expansion of coordination number of antimony. And triphenyl bismuth reacts with hydrogen halide and there is a formation of trichlorobismuth plus 3-benzene. So these three phenyl groups replaced by halogens. So in this way there is a reaction of organometallic compound with protic reagents such as water, alcohol, that is methanol, and hydrogen halide. At the time of exam you remember one or two reactions from each group. Okay, so this is about the alkylation, arylation reactions and reactions with protic reagents of organometallic compound.